The third flight test of the Starship vehicle could launch on March 14th pending regulatory approval. This is what SpaceX said after the Starship stack for the third test flight completed its launch rehearsal, loaded more than 10 million pounds of propellant onto Starship 28 and Super Heavy Booster 10, and took the flight-like countdown to T10 seconds. This rehearsal launch was conducted after both the ship and the booster completed their static fires in December 2023. The third flight test aims to build on what we've learned from previous flights while attempting a number of ambitious objectives. SpaceX has updated its website counting down and timing milestones for the third flight with ambitious tests of the ship in space. Let's break down this information and see what we can expect from the third test flight, starting with a countdown to loading fuel onto the vehicles. At T1 hour and 15 minutes, the SpaceX flight director conducts poll and verifies go for propellant load. As the orbital tank farm is vented in, the fuel and oxidizer are pumped toward the booster onto the launch pad and toward the ship through the ship quick disconnect. T53 minutes, ship locks, liquid oxygen, load underway. 2 minutes later, at T51 minutes, ship fuel, liquid methane, load underway. This precedence in loading fuel onto the ship before the booster is different in the countdown to the second flight, as they started with the booster first. T42 minutes, booster locks, liquid oxygen, load underway. T41 minutes, booster fuel, liquid methane, load underway. T19 minutes and 40 seconds, Raptor begins engine chill on booster and ship. T3 minutes and 30 seconds, booster propellant load complete. T2 minutes and 50 seconds, the ship propellant load complete. With both the ship and the booster containing their propellant, the countdown continues until T30 seconds, as the SpaceX flight director verifies go for launch. T10 seconds, the flame deflector activated. T3 seconds, the Raptor engine's ignition sequence begins. In T00, excitement guaranteed. T+2 seconds, liftoff. The booster 33 Raptor engines will lift the third flight stack from the launch pad into the air. T+52 seconds, the vehicle will reach max Q, moment of peak mechanical stress on the rocket. SpaceX hopes that all the booster engines will remain operational during ascent, after it succeeded in doing so on the second flight. T+2 minutes and 42 seconds, booster MECO, most engines cut off. The 20 outer ring engines and the 10 middle ring engines are cut off, while the 3 inner ring engines are kept running. Hot staging, Starship Raptor ignition and stage separation, at T+2 minutes and 44 seconds. This technique worked well on the second test flight. T+2 minutes and 55 seconds, booster boostback burn startup, where the 10 medium engines are restarted, along with the 3 internal ones, to perform the booster flip maneuver and give it some reverse thrust towards the water landing site. In the second test flight, during this burn, several engines began shutting down before one engine failed energetically, quickly cascading to a rapid unscheduled disassembly of the booster. The most likely root cause for the booster was determined to be filter blockage where liquid oxygen is supplied to the engines, leading to a loss of inlet pressure in engine oxidizer turbopumps that eventually resulted in one engine failing in a way that resulted in loss of the vehicle. On February 26, the Federal Aviation Administration (FAA) closed the investigation into the second Starship test flight and identified 17 corrective actions, 7 for the Super Heavy booster, including redesigning the vehicle's instrumentation, updated control system modeling, and re-evaluating engine analyses based on second flight data, and updated engine's control algorithms. Since the booster accident, SpaceX said it has implemented hardware changes in future booster tanks to improve propellant optimization capabilities and refined operations to increase reliability. Inside the aft section of the oxygen tank of Super Heavy Booster 10, there are 2 new rows of bracketry welds, which may very well be for some type of new slosh baffle type devices, which may help reduce fuel sloshing during booster boost-back maneuvering. Returning to the third flight path, the booster burn will last for 55 seconds. before shutdown at T plus 3 minutes and 50 seconds. T plus 6 minutes 36 seconds, the booster is transonic, followed by the booster landing burn startup at T plus 6 minutes 46 seconds, and will last for 18 seconds until shutdown at T plus 7 minutes 4 seconds. After running the ship's engines for 5 minutes and 51 seconds, the ship engines cut off at T plus 8 minutes and 35 seconds. During the second test flight, a leak in the rear section of the Starship 25 that occurred when the liquid oxygen vent was initiated led to subsequent combustion and fires that led to a loss of communication between the ship flight computers. This resulted in all 6 engines shutting down before the climb was completed, followed by the autonomous flight safety system detecting a mission rule violation and activating the flight termination system, resulting in the vehicle crashing. The FAA has identified 10 corrective actions for the Starship vehicle, including vehicle hardware redesigns, operational changes, flammability analysis updates, installation of additional fire protections, and guidance and modeling updates. SpaceX said it has implemented hardware changes on upcoming Starship vehicles to improve leakage reduction, fire protection, and improved operations associated with the thrust hatch to increase reliability. And the pre-planned transition from the vehicle's Raptor engine's hydraulic power steering to an all-electric system also eliminates potential sources of flammability. Some of these changes can now be observed on the Starship of the third flight, Ship 28, when compared to the Starship that flew on the second flight, Ship 25. Up on the nose cone, the 2 header tank vents now sport cowbell diverters, which divert the vapors downwards. These may be for use as attitude control thrusters. Additional and redesigned Starlink terminals for Starlink terminals have been installed on the leeward side of the nose cone, replacing the single terminal that used to be integrated with the payload bay access hatch on Ship 25. This likely allows the ship to have a more stable connection during flight, alongside the existing radio antennas. Moving to the tank section, the positions of the liquid methane tank pressure relief vents were changed from being located closest to the heat shield on Ship 25 to being located closer together on Ship 28. On the liquid oxygen tank, the number of uncovered pressure relief valves was lowered from 2 on Ship 25 to only 1 vent placed on the left side of the Ship 28. The 2 small diverted thrusters on the liquid oxygen tank, for use when roll control is needed, have been moved closer to the heat shield on Ship 28. In addition, the 2 vents with cowbell diverters on liquid oxygen tank have been deleted entirely on Ship 28. Electric thrust vector control. Starship 28 will be the first ship to bring it to flight. This update replaces the hydraulic pistons on the engines with electric actuators, eliminating potential sources of flammability. It also removes the associated hydraulic systems on the ship's side. The hydraulic power unit in the ship's skirt is no longer present. This reduces mass and complexity and increases redundancy. Returning to the path of the third flight, T plus 11 minutes and 56 seconds, payload door open. SpaceX will conduct a payload door opening test. In December, an opening and closing test of the ship's payload door was conducted on Ship 28. With the door open in flight environment, SpaceX will be able to collect the data it needs in preparation for launching Starlink satellites in future missions. T plus 24 minutes 31 seconds, propellant transfer demonstration, where the propellant will be transferred from the header tanks to the main tanks. This is important for NASA's Artemis program. T plus 40 minutes 46 seconds, Raptor in space relight demonstration. On December 29th, SpaceX conducted a single-engine fire test on Starship 28, describing it as ignition of a single Raptor engine demonstrating the flight-like startup for an in-space burn. T plus 49 minutes and 5 seconds Starship entry. The spacecraft's thermal protection system will be tested in a real return environment from space to ensure the durability and ability of the thermal tiles to withstand the heat of entry into the atmosphere. T plus 1 hour, 2 minutes 16 seconds Starship is transonic. T plus 1 hour, 3 minutes and 4 seconds Starship subsonic. T plus 1 hour, for minutes and 39 seconds. An exciting landing.